Welcome students, and this is online classes which I am taking it from the unit 5, which is what we call it as a memory organization in computer architectures. So I hope this videos might able to understand it more clearly and have an overview ideas of what is a memory and the different aspects of it. So let us see what is a memory first of all. So a memory unit, as you know, that there are many different memories are available in the market, but all those memories I'm clubbing it together. You have primary memory, you have already that you have secondary or auxiliary memory, call it, then you have registers, then you have is the cache memory. You have so many memory devices are there, but as a collection I can define a memory unit is a collection of storage unit or devices together. The memory unit stores the binary informations in the form of bits, as you know already, that whatever we are typing it or if we are storing any videos, it is not stored as a streams of videos, but rather it is converted into bits and bytes, and then it is stored into the memory. So generally memory or the storage can be classified into two categories. The first one you have is the volatile memory, and the second category is what we call it as an non-volatile memory. A volatile memory is a memory, all those memory systems where the informations are stored temporarily, that is till the power is on, the information will be there, and once you switch off the power, all the information, whatever you have written it or whatever you are seeing it, that will be lost. The another category which we have it is a non-volatile memory, and these are those all memory devices, or what we call it as a permanent memory storage. We can say that it is a permanent memory storage devices that will be stored permanently even after the power is switched off. So as I was telling you that there are many memory devices are there in the computer systems, and this all memory can be visualized in the form of memory hierarchy. We call it as a memory hierarchy. So as in the class also I was discussing this same thing many times, that it is the memory hierarchy is a pyramid structure. It looks like a pyramid structure where you have on the very top of it you have is the register memory, then just below the register memory you have is the cache memory, and then you have is the main memory, and then finally you have it is the auxiliary memory, or what we call it as a secondary memory also. So the largest space which we have in the memory system is basically the auxiliary memory, and just on top of it is the main memory where the information are not stored permanently. It is basically will be there, but once you switch off the system, whatever you have stored into this particular, whatever the information you had it in the main memory, that will be lost. And on top of this is again a cache memory, and then finally you have is the register memory. So you see that cache memory and the main memory, these two memories are basically the volatile memory, whereas the registers and the magnet and the secondary memories, they are the non-volatile memories. That is, the information will be stored permanently here, whatever you are storing. So in memory hierarchy, how can we define it? So I say that the total memory capacity of a computers can be visualized by a hierarchy of components. The memory hierarchy system consists of all storage devices contained in the computer systems, from slow auxiliary memory to fast main memory and the smaller cache memory. Now let us see what is this auxiliary memory is. Auxiliary memory basically are the secondary memory devices which may be attached to the computer systems or may not be. Say for example, we can say that the magnetic tape, discs, CD, floppy, pen drive, memory drive, they are all considered to be as a auxiliary memory. But here, this auxiliary memory, the access time is very, very great. That is, to retrieve the information from this from this auxiliary memory will be very high. That is maybe 1000 times or 2000 times more than the main memory which we have it in the computer. Hence, therefore, this auxiliary memory is kept at the bottom of the hierarchy. So at the bottom of the hierarchy, which is quite a bigger places, so this place, that is this place, is your auxiliary memory, and its access time is the very, very high, very, very high. On top of this auxiliary memory you have is the main memory, which occupies the central positions because it is equipped to communicate directly with the CPU and with auxiliary memory devices through input-output process. We will see later on, we will discuss later on this input and the output process also. So when the program, if it is not residing in the main memory and it is needed by the CPU, they are brought it from the auxiliary memory. Program not currently needed in the main memory are transferred into the auxiliary memory to provide space in the main memory for other programs and are current in use. That is, since I told you that the main memory is very small amount of memory, the space is very small, so we cannot store everything in the main memory, and it is a volatile memory also, so we cannot store the information permanently over there. So generally we store the information in the secondary or the auxiliary memory. But whatever is needed by the CPU, that is being taken it from the main memory, that is the primary memory. So when the CPU wants something to execute, it see first in the primary memory, and if it is not found in the primary memory, then it is the primary memory takes the information from the auxiliary memory and stored it there, and then it gives it to the CPU for the execution. And then on the top of this, the pyramid structure you have is the cache memory, which is also very important memory systems. So cache memory is used to store program or data which is currently being executed in the CPU. Since the access time of the cache memory is very fast, so if anything's needed by the CPU and if the information is available in the cache memory, then it can be sent directly to the CPU for the execution. And if the information is not found in the cache memory, then it goes and see in the primary memory. And if it is not found again in the primary memory, then it is being taken it from the auxiliary memory. So the cache memory is, if you have a systems with the cache memory, then your access time will be very faster. Memory access time will be faster. So what is this memory access? So each memory type, whatever we have seen it, that is, you have is the very bottom of it is the secondary memory or the auxiliary memory. Then on top of it was your primary memory. Then on top of it was a you have is the cache memory, and the very topmost and the top of the pyramid you have is the registers. Registers are very, very small in number also and very small in size also. So in the registers only those informations are stored which are needed by the CPU for the execution. Since we have very less number of registers available in a CPU, as well as very the memory capacity is very low, very less. So this 4 types of memories which computer systems are using. Okay, so if you see from bottom to the top, you see the size is decreasing as we keep on going from bottom to the top. The size of the memory is decreasing it, but when we come down from top to the bottom, that is from registers to the auxiliary memory, the access time is increasing it. That means the more bigger memory system, the more access time it is going to take it. Now let us see what are the different access method we have it. So each memory system is a collection of numerous memory locations. To access the data from any memory, first it must be located and then the data is read from the memory. So there are 3 methods to access the information from the memory. The first one you have is a random access. Here the main memories are random access memories, in which each memory location has a unique address. So using this unique address, any memory location can be reached in the same amount of time in any order. Then you have next is the sequential access. This methods allow memory access in sequence or in order. And then you have the last category is the direct access. You can access it directly also. So in this mode, information is stored in a track, and each track has a separate read and write head. Okay, so this is about the how we can access the memory. That is, you have random access where the information are randomly accessed from the memory location. And then you have a sequential, it will start searching it from the very beginning, and then it keeps on going one after another, and whatever the information we wanted that particular location, if it has reached, then it will access this. And the third category we have is the direct access, which is the best access method. And in this method, the information is stored in the form of track rather than sequentially, and each track has a separate read and write head through which it is going to read. Now let us come back again to the main memory. The memory unit that communicate directly with the CPU or auxiliary memory and the cache memory is called the main memory. So that is why I was telling that it holds the central positions. That means if we want anything to communicate directly with the CPU or the memory which is communicating directly with the CPU, auxiliary memory and the cache memory is basically called the main memory. It is the central storage unit of the computer systems. It is a large and a fast memory used to store data during the computer operations. Main memories, as you know, is made up of, can be either RAM or ROM. The RAM, integrated circuit chip holding the major shares here. So RAM means random access memory. So you have there are different types of random access memory. We have DRAM, dynamic RAM we call it, is made of capacitor and transistors and must be refreshed every 10 or 100 microseconds. It is slower and cheaper than the SRAM basically. Then you have second is the SRAM, that is static RAM, has a 6 transistor circuit in each cells and retain data until power off. And then you have another type of RAM also, what we call it is NVRAM, that is non-volatile RAM, retains its data even when the computer or the power is turned off. And the basically non-volatile RAM is your flash memory. So all this RAM, if you switch off the power, the information will be lost. But NVRAM, the information will be retained and even if the power is also switched off. Then you have another is the ROM, that is called read-only memory, is a non-volatile and is more like permanent storage for information. So ROM basically is not a volatile memory, it is a non-volatile memory. Okay, because it stores the information permanently. It also stores the bootstrap loader programs to load and start the operating systems when the computer is turned off. So basically RAM is used, it's a very small amount of memory and only it stores basically the programs to start your computers, that is the operating systems. It only stores the location where the operating system is stored and it exists and then it is being read. Then you have another is the auxiliary memory. So devices that provides backup storage are called the auxiliary memory. So any devices which we are using it for backup are called basically auxiliary. For example, magnetic discs, tape or CD or maybe hard disks, they are all basically auxiliary memory devices. So, and then you have is the cache memory. Cache memory is a very special kind of memory systems which is located in between your CPU and the main memory. The data or content of the main memory that are used again and again by the CPU are stored in the cache memory so that they can easily access the data in shorter time. That is, the program or the data which are needed by the CPU very frequently are only stored in this cache memory. Whenever the CPU need to access memory, it first checks in the cache memory. If the data is not found in the cache memory, then the CPU moves on to the main memory. It also transfers block of recent data into the cache and keep on deleting the old data in the cache to accommodate the new ones. Since it is very small, the cache memory is very small in size. So we cannot store all the information. So only those informations are stored which are needed, which are frequently needed by the CPU for execution. And the performance of the cache memory is measured in terms of a quantity called hit ratio. When the CPU refers to the memory and finds the word in the cache, it is set to produce a hit. And if the word is not found in the cache, it is in the main memory and then it counts as a miss. So the ratio of the number of hits to the total CPU reference to memory is called the hit ratio. So we can say that the hit ratio is equal to hit, that is if it is found in the cache memory, divided by hit plus miss. That is, hit means if it is information or data is there in the cache and miss means if the information